Hey guys, in this video, the lovely Mr. B is going to be talking to you about straight lines. Graphs of straight lines, drawing straight lines, and using them for things. This is all for your A-level maths. Now there are lots of examples worked through here nice and slowly for you, but if you want lots of examples to practice, then they're all waiting for you over on my website.
We are going to revise several aspects of straight lines, starting off with midpoints. So with midpoints, we've got two coordinates. We've got 1, 8, and we've got 6, 2. So if we imagine that we had a diagram for this, then we'd have 1, 8 on the diagram, and then we'd have 6, 2 on the diagram. So what we want for the midpoint is, if we imagine that there is a line in between the two coordinates, the midpoint is the coordinate in the middle. So our job is to find out the x and y coordinates of that point. Now, of course, we don't have a diagram of this, so this isn't something we can read off a diagram. So what we need to do is we need to have some kind of formula, some kind of method to do this without the diagram. So what we do is we take x1 and we take x2. So by x1 and x2, we just mean the first x coordinate and the second x coordinate, and we find the average of them, so we divide by 2. And we do the same thing with the y coordinates. We take y1 and we take y2, add them together, and we find the average of those two coordinates. Again, with y1 and y2 being the first and second y coordinate. Make sure the same way around, so x1 and y1 have to be from the same coordinate, x2 and y2 have to be from the same coordinate. So let's substitute into the formula. x1 is 1 and x2 is 6, so we add those together, which gives us 7, and we divide by 2, and that will give us 3.5. Do the same thing with y, so y1 is 8, y2 is 2, 8 plus 2 is 10, and divide by 2 will give us 5. So our midpoint is at 3.55, and you can usually label the midpoint as M, but you can use other letters to label it. So let's try another example. So again, we want to add together x1 and x2 and find the average of those two numbers. x1 is 4 and x2 is 1. Then we want to get y1 and y2 and find the average of those. So y1 is -1, y2 is -6. So let's give the substitution a go. That's going to be 4 plus 1 divided by 2, which is going to give us 2.5. For our second one, we're going to have -1 plus -6, all divided by 2. All together with -7 and divide by 2. That gives us -3.5. So now we can write down our coordinate. It's 2.5 and -3.5, and that is the midpoint between the two coordinates we're given. The next thing to look at is the length of lines. So we have two coordinates again. We've got 6, 2. And we've got 6, 6. And again, we don't have a diagram for this, but if we imagine that we did have a diagram, then we'd have something like this. So we'd have 6, 2, we'd have 6, 6, and we want the distance in between the two coordinates. Now, if you have a horizontal or a straight line, the way you can tell is that two of the coordinates will match. So for example, the x coordinates are both 6. So we know that we've got a straight line. And so it's a simple matter of just looking at the difference between the y coordinates. So 6 take away 2 is 4, so we know that we have a distance of 4 between those two coordinates. In our next example, we've got the coordinate 9, 5 and 4, 1, and neither the x or the y coordinates match, so we don't have a straight line here, and this is where this topic gets a little bit more difficult. Now again, if we imagine that we did have a diagram for this, so we had 4, 1 and we had 9, 5, we want the length of the line in between the two. So how do we find it? Well, a nice shortcut for this is actually you can form a triangle out of this, because the x and the y axes are straight lines and they are perpendicular to each other, which means you have a right angle in between. So we have a right angle triangle. If you have a right angle triangle, that means you can use Pythagoras theorem to work out the length. So all we need to do is work out the straight sides. Let's look at the x coordinates first. So we've got 9 and we've got 4. That gives us 5. So the x distance is 5. Then we'll look at the y's. So we have 5 and we have 1. That gives us 4. The x distance is 4. So now we can use Pythagoras theorem. So a squared plus b squared is equal to c squared. Call the short sides a and b in either order, and the long side c. So that would be 5 squared plus 4 squared is equal to c squared. So 25 plus 16. And 25 plus 16 is going to give us 41. So if 41 is c squared, square root both sides. C is going to be the square root of 41. Now, if you're being asked for an exact answer, then the square root of 41 is how we're going to leave it. But we're not being asked for an exact answer. We're being asked to kind of write it as a decimal. Then we could write 6.4. Now, that's from my calculator, 6.403124237. It's an irrational number. This is going to keep going. So we just want to round it to maybe one decimal place for this one. If you don't want to round it, again, just write root. We can also write the entire thing as a formula. So the length of the line is going to be x1 minus x2 squared plus y1 minus y2 squared. And then it's going to be the square root of the entire thing. Don't worry about which way around x1 and x2 are, and the same with the y's, because, if it's the other way around, you will get a negative number, but squaring negative numbers actually gets rid of the negative, meaning you'll get the same answer. It's just when you have the x1 and the x2 and the y1 and the y2, make sure they come from the same coordinate. So, for example, if the 9 is x1, the 5 must be the y1. That can't be the y2. The 1s have got to come from the same coordinate, and the 2s have got to come from the same coordinate as well. So that's the easy ones, is going to be find the y-intercept of a line. Now, if a line's in the form y is equal to mx plus c, then the y-intercept is actually the plus c. What you'll notice with this question is that the line is not in this form. So we have to rearrange it. So we take the equation 4x minus 7y is equal to 11. Now we're going to want a positive y for this. So let's add 7y to both sides. We want y in its own. Let's take away 11 from both sides. And we want 1y equals, and we've got 7y. So let's divide through by 7. Now I'm not actually going to divide by 7. I don't want to do that because it's going to be 4 divided by 7. It's going to be 11 divided by 7. So what I can do is I can just leave those as fractions. It might be helpful just to write it the same way around. So y is equal to 4/7 of x, take away 11/7. So the negative 11/7 is the y-intercept. Perhaps I might want to change it to a mixed number. So 11 divided by 7, it's going to be 1 remainder 4. So that's 1 and 4/7. That's going to be the y-intercept. And that's a place on the graph where the line crosses over the y-axis. If you're asked for the coordinate of the y-intercept, then it's always when x is equal to 0. Cross the y-axis when x is at 0, because that's where the y-axis is. The y-axis goes through x at 0. Next, we'll look at parallel and perpendicular. And these are all about the gradient. So again, when we look at our kind of basic straight line form, y is equal to mx plus c, the gradient, the steepness of the line, is the m. Now, how do you show that two lines are parallel? So you look at the gradient. So the gradient of the first one is 6, and the gradient of the second one is 6. You see, they both have the same gradient. So you say they've got an equal gradient, therefore they're parallel, because parallel lines have got the same gradient. So that's all you need to write. So our last example had a positive gradient. In this one, we've got -7 for our first line and -7 for our second line. So you can also have negative gradients. And again, all you do is you say they have equal gradients, therefore it's parallel. And for our next example, we've got the gradient of 2/5 on the first line and 2/5 on the second line. So again, these are going to be parallel, they have the same gradient. But what I want to show you is that you can have whole numbers, you can have fractions for your gradient, you can have negative numbers, and you can have positive numbers. For our next example, when we look at the gradients, it looks like we've got 4 and 6 for our gradients. But what you'll notice is these are not in the form y equals mx plus c. So what we should really do first is actually rearrange to make them in these formats. So let's have a look at our first line. So we've got 4x plus 8y is equal to 13. I want to get y in its own, so let's take 4x away from both sides, divide both sides by 8, and 4 divided by 8, we're going to simplify that in a moment, that'll be a half. Let's just swap around the y-intercept and the gradient, get in the format we understand. So that's going to be y is equal to -12x plus 13/8. And we can do 13 divided by 8. It's going to give us 1 remainder 5. So that's 1 1/8. So that's our first line. And now we'll see that the gradient is actually -1/2. It wasn't 4. Let's have a look at the second line. So we have 6x, take away 3y is equal to 14. So let's take 6x away from both sides. And then let's divide through by -3. So 14 divided by -3, put it over 3, make it negative. -6 divided by 3. So double negative, make it positive. And 6/3, we can simplify that, it's going to be 2. So y is going to be equal to 2x, take away 14/3, And again, we can do that. 14 divided by 3 is going to give us 4 remainder 2. So it'll be 4 and 2/3. And again, the gradient now looks different. The gradient is 2. It's not 6. And the trick is, if y isn't 1y, there's a coefficient on the y, there's a number on the y, then that means we're going to have to do some things to get the actual true gradient. Now, we're being asked to show that these are perpendicular. So we're not being asked to show the parallel. Now, they're not the same, so they're not parallel. So what does perpendicular mean? So perpendicular lines are at the negative reciprocal to each other. So what does a negative reciprocal mean? So there's two elements to negative reciprocal. Let's look at both of these as a fraction. Our first gradient is a half, and our second gradient is 2. Now we can write whole numbers as fractions. 2 is the same as 2 over 1. Now look at these two gradients. We have the same numbers, they're just flipped around. The numerator and the denominator are switched. The next thing is that the half is negative, but the 2 is positive. And so this is what we mean by a negative reciprocal. They have different signs, and written as a fraction, they are flipped upside down. So for our final answer, we just write 2. Or let's start off with the negative half, actually. Negative half is a negative reciprocal of 2. Therefore, the line is perpendicular. So moving on to our last example like this, again, we can see that the y's are not 1y. We've got 8y and negative 12y. So we need to rearrange first to get our lines into the form y equals mx plus c. So we can see the gradient m. So 3x plus 8y equals 15. Let's take 3x away from both sides and divide both sides by 8. Let's rearrange to put the x first. So that's negative 3/8 of x. This will be plus 15/8. So 15 divided by 8 is going to be 1 remainder 7. So that's 1 and 7/8. So our gradient is negative 3/8. Let's look at the second line. 32x minus 12y is equal to 15. So let's take the 32x away from both sides. We want to get y on its own. Let's divide it through by negative 12. Y is equal to, so 15, we're going to divide it by 12 and make it negative. And then the 32, we're going to divide that by 12, make that negative, but it's already negative. Double negatives will make it positive. So now let's rearrange it. 32 over 12x. So we want to be dividing 32 by 12. So 36 is 3/12, so it's actually going to be 2 remainder 8, 2 and 8/12, and we can simplify 8/12. We can divide that through by 4, which will give us 2/3. So it's 2 and 2/3. Then we have the negative 15/12. Now again, that's something we can simplify. We can divide it through by 3, which will give us 5 over 4, and we could do 5 divided by 4. It's 1 remainder 1. Just write your remainder over the denominator. It's 1 1/4. Okay, so how can we show these negative reciprocals? Because we've been asked to show that they are perpendicular. Now, the first one's a nice format. We've got negative 3/8, that's fine. So 2 and 2/3. We want to write this as a top-heavy fraction. So 2 times 3 will give us 6, add it on top. That's going to be 8/3, and it's positive. And so now I can see that they are negative reciprocals of each other. One's positive, one's negative, and the numbers in the fraction are flipped. So we can say negative 3/8 is a negative reciprocal of 8/3. Therefore, the lines are perpendicular. Now, I'm going to bring some of these facts together to find the equation of some lines. Now, with straight lines, the equation should always be in the format y is equal to mx plus c. And it'll give us some clues in our question. So we're told the gradient is negative 1/4. So we can write y is equal to a negative quarter x plus c. And then for our second step, we're told it passes through the coordinate 1 and 3/4. And that is an x and a y coordinate. So we can substitute those values in for x and y, and that will give us c. So y is 4/4, 3/4 rather. Then we have negative 1/4 x, and now x is going to be swapped for 1. And then all we have left is this c. So this is going to give us a c. So let's work it out. If we multiply a negative quarter by 1, we get a negative quarter. So 3/4 is equal to a negative quarter plus c. And then we add a quarter to both sides. That will give us 4/4 is equal to c. And 4/4 is 1. Therefore, c is 1. That means that we can now write down our final equation. Y is equal to m, which was negative 1/4, x plus c, which we just found out was 1. So there's the equation of our line. So 2 steps. Substitute in the gradient and then substitute in the x and y coordinate you've been given as a clue. For our next line, start off with y is equal to mx plus c. And we want to find the gradient first. Now we're not told the gradient directly, but we're told the equation of a different line which is parallel to it, is y equals 8x plus 9. So the gradient there is 8. So it is telling us what the gradient's going to be. It's going to be y is equal to 8x plus c. So the gradient might be hidden behind parallel or perpendicular facts. Then we have a coordinate. We've got -4, -36, which gives us an x and a y value on the line we can substitute in. So we can say -36 is equal to 8x, x -4, plus c. So we can start to work this out. 8 times -4 first, that's going to be -32. So -36 is equal to -32 plus c. So if we add 32 to both sides, that means that -4 is equal to c. And so now we have our equation. Y is equal to 8x take away 4. For our next example, we start off the same way. Y equals mx plus c. But this time our gradient clue is a little bit different. Yeah, again, we're given a different line as a clue, which has a gradient of 1/6. But this line is perpendicular. That means that the gradient is going to be the negative reciprocal. So take the gradient, 1/6. And so for the negative reciprocal, this is positive. So the negative reciprocal is going to be negative. You can start off with a negative one, and so if you make a negative gradient negative, it's going to end up being positive. So watch over double negatives here. The negative reciprocal is not always going to end up being a negative number. And then just flip the fraction upside down. 1/6 becomes 6/1. And 6/1, everything's over 1. 6 divided by 1 is 6. It's just going to be a whole number. So we can write y to be equal to -6x plus c. Then we have a coordinate that it passes through, which is going to give us an x and y value that we'll substitute in. So y is going to be -19, x is going to be 2. So that's going to give us -6 lots of 2. So working that out, we're going to have -19 is equal to -12 plus c, and add 12 to both sides. -7 is c. Then we can write down our final equation. Y is equal to 6x take away 7. And that's perpendicular to the 1/6x plus 5. And so where those two lines cross, they'll be crossed in at a right angle. For our next example, again, we always start off the same way. Y equals mx plus c. But for this one, there's no clear evidence for gradient being given to us. We're just given 2 points that the line passes through. So how can we find the gradient from that? Now, we don't have a diagram here, but let's imagine that we did have a diagram. So we might have -8, 2 down here, and we might have 4, 8 up here. And so we want the gradient of this line. We want to know how steep the line is. Now, the gradient, m, is equal to the change in y over the change in x. So when we have a look at this, we can think of, well, what's going to be the change in y? So the change in y, let's have a look at the y coordinates. We've got 2 and we've got 8. So 8 take away 2 is 6. So the change in y is 6. Then look at x. So with the x coordinates, we've got 4 and -8. Now, do you take away the same way around? So we started off taking away with the 8. So what's next to the 8? The 4. With 4, take away the -8. Because the double negative, that's going to give us 12. The change in x is 12. So we've got 6/12. Well, that's a half. So that tells us that the gradient is going to be a half. Y is equal to a half x, 6/12x, the same thing, plus c. Now we've done that, again, we're going to substitute in a line, a point on the line, and we've got 2 alternatives. Now you can substitute in either the 4/8 or the -8, 2. I'm going to substitute the 4/8 just because it's got positive numbers and it'll probably make the calculation easier. So we've got an x and a y coordinate substitute. Y is 8, x is 4. So that's going to give us a half of 4 to work out, which is 2. So altogether, we've got 8 is equal to 2 plus c. Take 2 away from both sides. C is equal to 6. So our final expression for this, final equation, is going to be y is equal to a half x plus 6. Now, the final example works the same as the previous one. We want to find y equals mx plus c, but we've been given 2 coordinates as clues. Now, you could work out the way we did the last one, but what I'm going to do here is I'm going to introduce a formula for this. Now, I said that the gradient, m, is equal to the change in y over the change in x. So we can make a formula out of this. So we can say that gradient is equal to, how do we get the change in y? So we take one of the y coordinates and we take away the other y coordinate from it. Then how do we do the change in x? Again, we take one of the x coordinates and take away the other x coordinate. Now, which coordinate do you call x1, y1? And which coordinate do you call x2, y2. Well, it doesn't matter. And what you'll find is no matter which way around you put these, you're going to get the same answer. So let's call the first one x1, y1, and the second one x2, y2. And let's do the substitution. So the gradient's going to be equal to y1 was 1 and y2 was 3, and divide it by y1 was -8 and x2 is -6. That's negative 6. So there's our substitution. So we could do 1 take away 3 is -2. -8 could be +6. It's double negative. That'd be -2. So divide the number by itself and you get 1. Now, if we did the 1s and the 2s the other way around, we'll get the same answer. We will get 1. What's important here is that when you substitute in x1 and y1, for example, you don't switch sides. You don't say that x1 is -8 and then y1 is 3 from the other coordinate. They've got to be from the same coordinates. So you've got to be consistent with the way you select your numbers here. So now we know the gradient's 1. We can write y is equal to 1x plus c. And then we can substitute in either the x1, y1 or the x2, y2. There's not a lot of difference in either. I'll just go for the first one. So y is going to be equal to 1, x -8. There's no multiplication here because the gradient was 1, so you multiply by 1, it stays the same. So let's add 8 to both sides. And that's going to give us that 9 is equal to c. So our final equation is going to be y is equal to 1x plus 9.
Ouch! This is why in some videos I have unexplained scratches.